Imagine standing on the edge of human understanding, gazing at the vastness of the cosmos with a feeling of awe and wonder. As you peer deeper into the universe, you realize that what was once thought to be an unassailable truth might not be true after all. Everything we thought we knew about the universe, how it began, how it evolved, and the laws that govern its existence, could be built on a foundation far less solid than we ever imagined. Thanks to the groundbreaking capabilities of the James Webb Space Telescope, humanity has been granted a new opportunity to witness the cosmos in ways we never thought possible. The discoveries it is making right now are not just enlightening, they are shaking the very foundations of modern astronomy, offering a glimpse into a universe that may not behave as we once thought. This new reality could be nothing short of revolutionary. The Webb Telescope, which is the most advanced space observatory humanity has ever created, is providing images and data that challenge nearly everything we have understood about the formation and development of the universe. One of the most astonishing aspects of the findings from the Webb is that it is uncovering galaxies so ancient that they shouldn't even exist according to our current models of cosmic evolution. These galaxies, appearing to be fully developed and structured, are showing up in an era when, according to the Big Bang Theory, the universe was supposed to be a chaotic, hot, and dark void, devoid of any complex structures. To fully grasp the enormity of this revelation, we need to understand just how much of a deviation these findings are from the predictions that astronomers have worked with for decades. According to the traditional understanding of the Big Bang, after the universe began, there was a period of time known as the Dark Ages. This epoch, which lasted for hundreds of millions of years after the Big Bang, was thought to be a time of little to no structure. It was a time when stars were beginning to form, but galaxies had yet to take shape. In this view, the universe was mostly a dark, turbulent place with only hydrogen and helium existing in abundance. Stars, and later galaxies, would begin to form from these primordial gases. Yet, the James Webb Space Telescope, which has peered deeper into the universe than any telescope before it, has found something extraordinary: galaxies that existed 13.5 or 13.6 billion years ago, which is nearly the same age as the universe itself. These galaxies appear to be highly developed, displaying complex structures and well-formed shapes, much like the galaxies we observe in the present-day universe. For scientists, this presents an astronomical mystery. If these galaxies existed so long ago, during a time that was supposed to be devoid of organized structure, how could they have formed so early and so fully developed? This question is one of the most puzzling aspects of the Webb's findings, and it has sparked intense debates in the scientific community. Some researchers are proposing that perhaps the early universe was not as dark and void of structure as we thought. These newly discovered galaxies might not be anomalies, but rather a normal feature of the early universe, indicating that the processes that formed galaxies may have occurred far earlier than previously believed. In other words, the early universe might have been far more developed and structured than our models suggest. If these galaxies are confirmed to be as ancient as they appear, then our understanding of cosmic history may need to be completely rewritten. This idea has serious implications for our understanding of the Big Bang Theory itself. According to the traditional model, after the Big Bang, the universe underwent a process of rapid expansion known as cosmic inflation, followed by a period of cooling and the formation of the first stars. The galaxies we now see in the universe were thought to have formed much later, through the gradual accumulation of gas and dust that coalesced under the force of gravity. But these new Webb discoveries are throwing this picture into question. If highly structured galaxies already existed so close to the time of the Big Bang, then there are serious implications for our understanding of the universe's early history and the timeline of its development. Were galaxies forming much earlier than expected? Were the processes that led to the formation of these galaxies different from what we assumed? These are questions that the Webb telescope is forcing us to ask. The implications of these findings extend beyond just the formation of galaxies. They also challenge the entire framework of cosmology. Our current understanding of the universe is built on several key assumptions, all of which are now being tested by the Webb telescope's discoveries. For example, one of the fundamental ideas of cosmology is that the universe is expanding. This theory, first proposed by Edwin Hubble in the 1920s, has been supported by decades of observations showing that galaxies are moving away from each other. This expansion is considered one of the most important pieces of evidence for the Big Bang model of the universe. However, the Webb telescope is providing new data that could potentially alter our understanding of this expansion. Hubble's observations were groundbreaking in their time, and they led to the development of the modern understanding of an expanding universe. However, as Webb reveals deeper layers of the cosmos, we are confronted with new evidence that challenges this view. For example, the Webb telescope is providing data on galaxies that appear to be moving in ways that don't perfectly match our expectations. While this could be due to the limitations of our current models, it is also possible that we have misunderstood certain aspects of the universe's expansion. This is one of the fundamental assumptions that has supported the Big Bang theory, and if new evidence suggests that the universe is not expanding in the way we thought, it could require a complete re-evaluation of how we understand the cosmos. Another key piece of the puzzle that the Webb telescope is helping to unravel is the nature of dark matter and dark energy. These two mysterious components of the universe make up the majority of its mass-energy content, yet their true nature remains largely unknown. Dark matter, which doesn't emit, absorb, or reflect light, is believed to play a crucial role in the formation of galaxies, but its exact properties are still a mystery. Similarly, dark energy, which is thought to be responsible for the accelerated expansion of the universe, remains elusive. As the Webb telescope observes galaxies at unprecedented distances, it may provide new clues that help us understand the role of dark matter and dark energy in the evolution of the universe. These discoveries could lead to a deeper understanding of the forces that shape the cosmos, and could potentially lead to breakthroughs in fundamental physics. Moreover, the Webb telescope's ability to capture light from galaxies that existed 13.5 billion years ago presents an opportunity to study the composition of the early universe in unprecedented detail. The telescope's instruments are capable of analyzing the light from these distant galaxies, breaking it down into its constituent parts to reveal which elements dominated the early cosmos. According to the Big Bang model, the universe began as a hot, dense ball of mostly hydrogen and helium. The heavier elements, such as carbon, oxygen, and nitrogen, were supposed to have formed much later, through the process of star formation and supernova explosions. However, the Webb telescope is showing us that these heavy elements were already present in the early galaxies, which suggests that these galaxies were much more developed than expected. This raises the question, if heavy elements were present so early in the universe, how could galaxies have formed without them? This is a question that scientists are grappling with as they analyze the Webb's data. If these findings are confirmed, it would have profound implications for our understanding of cosmic history. It would suggest that the processes of galaxy formation were much more complex than we previously thought, and that the early universe may have been far more diverse and structured than our models allow. This could lead to a major revision of our understanding of how the universe evolved, and could even challenge the very idea of a beginning to the universe itself. If galaxies were forming so early in cosmic history, does that mean that the universe has always been in a state of development, without a clear starting point? Could the universe be infinite in time, with no true beginning or end? These are questions that the Webb telescope is forcing us to consider. The excitement surrounding the Webb telescope's discoveries is palpable. For scientists, this is a moment of both awe and trepidation. After all, if these findings are confirmed, it would mean that the entire framework of modern cosmology is at risk of collapsing. For decades, the Big Bang theory has been the cornerstone of our understanding of the universe. It has guided research, shaped our thinking, and provided a model for understanding everything from the formation of galaxies to the expansion of the universe. But now, with these new discoveries, that theory is being questioned in ways that were previously unimaginable. Some researchers are already proposing alternative models that could explain the Webb's findings, while others are grappling with the possibility that our understanding of the universe's origins is fundamentally flawed. But amid all the uncertainty, there is also a sense of excitement. The Webb telescope is providing us with an unprecedented view of the universe, and with each new image and piece of data, we are inching closer to answers to some of the most profound questions in science. While the challenges to our current models are undeniable, they also present an incredible opportunity for growth and discovery. Just as scientists once had to grapple with the idea that the Earth was not the center of the universe, they may now have to come to terms with the idea that our universe is far more complex and mysterious than we ever imagined. As we continue to analyze the data from the Webb telescope, one thing is certain: the universe is full of surprises. With each new discovery, we are learning more about the cosmos and our place within it. And while the answers may be elusive, the journey of discovery is just beginning. For the first time in history, we are able to look deeper into the universe than ever before, and with that ability comes the potential for a revolution in our understanding of the cosmos. Whether we are on the cusp of uncovering new truths about the universe's origins, or simply peeling back the layers of a mystery that will take centuries to fully understand, one thing is clear: the universe is full of secrets waiting to be discovered, and the James Webb Space Telescope is opening the door to a new era of exploration and discovery. In the end, the question that remains is not just about what the universe is, but about how much we are willing to revise our understanding in the face of new evidence. For centuries, humanity has sought answers to the mysteries of the cosmos, and now, with the help of the James Webb Space Telescope, we are closer than ever to uncovering those truths. As we continue to look deeper into the universe, we are bound to face more questions, more challenges, and more opportunities for discovery. And as we venture into the unknown, we must remain open to the possibility that our understanding of the universe is still evolving, just as the universe itself continues to evolve before our very eyes.